in order to show you ultimately kind of unbalanced chemical equations, I'm just going to jump right in there and talk about balanced chemical equations. So balanced chemical equations give you, I said, quantitative information. They tell you the recipe. Quantitative. Oh my goodness, quantitative. Anyway, and not the quantitative information they're going to give you is relative amounts of both reactants that react and products that are formed. So relative amounts, that's what a balanced chemical equation will do for you. So in order to balance an equation, we use what I call these big numbers called stoichiometric coefficients. We basically associate, it's a big number, a stoichiometric coefficient, not as in like 1 to 100 big, but actually physically it's a big number. So we associate these big numbers with each of the reactants or products to kind of show you that it's balanced. Now, here's an example. The stoichiometric coefficient, for instance, can you see the big number? I don't know if it looks very big to you, but you see the 6 in front of the Cl2, that is a stoichiometric coefficient. The 4 in front of the PCl3, that's a stoichiometric coefficient. What do you think the stoichiometric coefficient is in front of the P4? If you said the number 1, you are right. So what this is saying is that if I have, and I usually kind of start out with it on kind of the small scale, and then we can scale it up to moles later. So what you start with are reactants, what you end with are products. So what this is saying is that you start with 1 P4 and 6 Cl2s, and you end with 4 PCl3s. Now, I mentioned the balancing part. I'm going to show you what I mean by that. The same number of atoms of phosphorus and chlorine need to be present on both sides of the what we call the reaction arrow. Okay, we need to have the same number of P's and Cl's. So let's check this out. How many P's do we have over here? Well, if we have one of these and there are 4 for each of them, okay, I'm liking 4. So we have 4 phosphoruses. Okay, if we have 6 Cl2 units, how many Cl's do we have? Well, 6 times 2 is 12. Do you buy that? I do. So how about this over here on the product side? We have 4 sets of PCl3s. So how many P's do we have? I'm liking 4. And how many Cl's do we have? Well, it's 4 times 3, or 12. So when I say balanced, does this look balanced? Okay, we have the same number of atoms of each type of element on either side of the reaction arrow. But do you see where new substances are formed, or a new substance is formed? Okay, so this is reactant, product. Okay, all right. So stoichiometric coefficients. Now this is also balanced. CH4, one of those, reacts with 2 O2s to form 1 CO2 plus 2 H2Os. Just for kicks, because we'll be doing more of this, let's go ahead, and I sometimes call this a brick wall, and we're going to compare what carbons, hydrogens, and oxygens on either side of the reaction arrow. So how many carbons do we have over here? I'm liking just 1. How many hydrogens? 4. How many oxygens? Well, we have 2 times 2. We also have 4 of those. Okay, let's go over here. What's the coefficient associated with the CO2? It is 1. So let's do a little tally over here. Let's see, carbons. How many carbons do we have? Oh, I'm getting just 1. How many hydrogens do we have? Oh, I'm getting 2 times 2, or 4 hydrogens. Now, when it comes to the oxygens, you have to recognize that we have an oxygen here, and we have actually, 2 oxygens? Well, two oxygens come here, and 2 oxygens come here. So how many oxygens do we have? We have 4. So now whoever balanced it did a great job, because they have the same number of atoms of each type of element on either side of the reaction arrow. Okay? Very good. Now one more thing before I kind of move on. Sometimes when we get rolling and I talk about the stoichiometry of a reaction as the stoichiometry is presented in the chemical equation, sometimes I'll go across and I'll see, do you see where this is? We have coefficients of 1, 2, 1, and 2. That's what coefficient. I'll just kind of call those out across the board. I like these little red squiggly marks here. Sometimes when I balance equations, I'll put it there because that reminds me that actually is the number when we apply this process that somebody already did for us to balance these equations. When we balance our own equations, that is the only place we can put a number. Okay? So it looks like I have one more coming up. Ooh, this one looks complicated. But it's not too bad if we go ahead and do a tally. I'm going to show you a trick. Okay? So here's my brick wall. I want to kind of tally both sides. Now, in the previous unit, we talked about this right here. Do you guys recognize what is the name of that? What is the SO4? Well, the SO4 is the sulfate. SO4 2-, that's the sulfate ion. And we have the aluminum here. I'm going to run out of room down here. So this is an ionic compound too. So what is the anion here? The anion here is the hydroxide ion. Very good. So I would kind of keep them kind of like this, Na plus and OH minus. I would go ahead and, 3 plus. I would keep them, the polyatomic ions, the sulfate and the hydroxide, I would kind of keep it bunched together. So now if we look at the product side, notice that we have sulfates we need to worry about in the sodium sulfate. We have aluminums we need to worry about in the aluminum hydroxide. We have sodiums we need to worry about in the sodium sulfate, and we have hydroxides we need to worry about in the aluminum hydroxide. All right then, let's see, sulfates. Well, I guess we need to start on the reactant side. So how many sulfates do we have over here? I'm liking 3. Do you guys buy that? Because of that right there. How many aluminums do we have? 2. How many sodiums do we have? We have 6. How many hydroxides do we have? We also have 6. I hope you buy that. So let's see if it matches up with 3, 2, 6, and 6 over here. So sulfates over here. How many sulfates do we have? 3. How many aluminums do we have? 2. How many sodiums do we have? Careful now. We have 6 sodiums. Did I say aluminums? We have 6 sodiums. Very good. And then how many hydroxides do we have? Again, be careful. We have 2 of these OH3s, so that I'm liking 6 for that too. Okay? So now match these guys over here, the 3, 2, 6, and 6, with these guys over here, the 3, 2, 6, and 6. So that's all to say that these coefficients of 1, 6, 2, and 3 for the 2 reactants and the 2 products, that does go ahead and balance it. So we're going to actually, here in a minute, talk about how you can balance them on your own. So a balanced equation tells you the reactants and the products, and which is what we call qualitative information, and then it also gives you those stoichiometric coefficients, those that gives you what I call recipe information or relative amounts. Okay. All right. So this actually kind of summarizes what I kind of showed you with those 3 examples of balanced equations a minute ago. If we draw the, if this is our reaction arrow, we have reactants going to form products, okay, and I kind of draw a brick wall here, and this tally of whatever atoms these are need to be represented over here, okay. So that's kind of what I'm saying there. So I've got some figures to go along with this idea and see what you think. Okay, so if we go with coefficients of 1 across the board here, okay, I have 1 here, 1 here, 1 here, and 1 here. Can you see anything that is not balanced? If you look at these pictures. I'll give you a hint. Well, are there a couple things not balanced? There are a couple things not balanced. Okay, I'm liking the oxygens. I can see 2 red balls over here with this O2, and actually 3 red balls over here. So oxygens are bad. Oops, sorry. Oxygens are messed up, and so are hydrogens. Hydrogens are those white things. Okay, I've got what 4 hydrogens over here and 2 hydrogens over here. So it's not balanced with stoichiometric coefficients of 1 across the board. Okay, so no, it's not balanced. That'd be boring anyway. Actually, there are definitely chemical reactions where the equations, the stoichiometric coefficients are all 1, but this one doesn't work for it. So what if we switch it up now, and what if we go with the stoichiometric coefficient of now 2 in front of the O2 and 2 in front of the H2O. Okay, now I hope this looks balanced. Here's the brick wall we've been talking about. I could put carbons, hydrogens, oxygens, carbons, hydrogens, oxygens, and we could knock out a number. So on this side, how many carbons do I have? I have 1 carbon. On this side, how many hydrogens do I have? I'm liking 4 hydrogens. On this side, how many oxygens do I have? Well, I have 2 times 2, and this is oxygen atoms, so I'm thinking what, 4? So over here on the product side, how many carbons do I have? Well, this is a 1. I have 1 carbon. How many hydrogens do I have? Well, I've got 2 waters, and each water has 2, so I'm liking 4 for that. And how many oxygens? Well, I have 2 H2Os, and each H2O has 1 oxygen, so I'm liking 2 for that. Oh, wait a minute. Oh, did you catch that? This is not right. What's wrong? How many oxygens do we have over here? Well, we got the 2 here, but we also have the 2 here. My bad. There we go. Now they're showing equal. It was already balanced with coefficients of 1, 2, 1, and 2. Okay, let's take another one. Or actually, we have a video, I guess. Let's